This is where we started making the logic brain series. This is a memory cell, the 4-bit memory cell. We are using a 74LS195 connected in parallel input, parallel output to store 4 bits. That's why you're seeing a 4-switch deep switch right next to it. This is what we did next. It's a priority selector. I hope you understood the logic of the priority selector. So basically, mine had 2 inputs, input A and input B. So if you turn on input A only, then the circuit will do task A only, because that's the only thing that it has at hand. If it has input B only, then input B is the one that's going to take all the CPU attention. If both of the inputs are on, now here is where the logic comes in. So when all inputs are on, the circuit decides which input is given more priority over the other one, and the time at which input A or B is turned on compared to the other one is set by these two potmeters right here, which vary the time at which input A can be given time compared to input B when both of the inputs are on. So that's basically how the priority selector operated. It checks all the input that it has. If all of them are on, then it's going to decide how to arrange those inputs to avoid crashing the system. So that's how the priority selector operated. Today, right here, we have a very simple circuit. This is the first sensor that the brain has as for now. It has a light sensor. So this is a light sensor. Right here we have an LDR, light dependent resistor. We have an NPN transistor right here. We have a 1K resistor which is connected to VCC, then connected to the collector of the NPN transistor. The base is connected to the LDR and the emitter to ground. Right here we have 2 ICs. These are LM358 ICs, dual comparator. So one IC has 2 comparators and the other one has 2, so combining them we'll have 4 comparators. That's why you're seeing 4 V references and 4 LEDs as output. So basically how this operates is each comparator has its own V reference, and the other input of that comparator comes from the sensor. So it compares those two inputs and gives an output if this LDR surpasses the V reference. So if it surpasses the V reference, then the comparator gives a 1 output which turns on the LEDs. So that's basically how the light sensor that I have here operates. I've done a lot of videos about light sensor. If you're interested to learn about different types of light sensors that I've done, circuits, then I'm going to put a link in the description for you to go and check on that. So if I can just turn this on for us to see how it operates. So the outputs are blue LEDs. As you can see, they are blue LEDs. So all of the inputs right now you can see are on, meaning that the circuit has detected that all of the set threshold have been met. That's why all LEDs are on. If I can start placing my hand on top of the sensor, you can see the first LED is turning off. Then if I continue going down further, you can see the next LED is off there, like that. If I continue going even further, it's kind of tough. You can see the third LED is off. Then the fourth one really needs a little bit of more darkness. I cannot reach that. Okay, so I hope you have understood how it operates. So if you can just show you again, I place my hand, then each LED starts going off, going off, going off. And if I could turn off this camera light, then this last LED could turn off also. So this is basically how the light sensor circuit will be operating. So how are we going to combine all of these circuits together? Because I'm going to add even more sensors. This is just one of them. I'm going to add a sound sensor, I'm going to add a proximity sensor, motion sensor, temperature sensor. You can see we have a lot of sensors. So how will the circuit be connected together? So let me just explain the logic of the circuit and how it will be operating. So right here we have four outputs of the sensors. right? So all of these outputs are going to be compared with the set value of the memory. So if I set the value of the memory to be 7 and to be 7 or 0 7 in 4-bit, so 0 1 1 1, that's 7 in binary. So if I set the memory to that value and or greater than that value, so each sensor, because it has it has 4 stages, then all of these are going to be compared. They're going to be compared with the memory, and if it reaches that threshold which the system is set, is going to enter a AND gate, which is going to give a 1 output. If that 1 output is going to come and is going to enter this priority selector, which is going to decide what to do, because it has detected that light is greater than, or light has been set to a greater amount of value. They are depending on how my brain or how my memory was set. So the circuit is going to check, okay, light sensor is giving an alarm. What else is giving an alarm? Maybe temperature sensor, maybe proximity, maybe sound. So all of these inputs are going to come here, and the brain is going to be deciding what to do with them. If it finds that if both temperature and light are on, then it's going to decide which one is going to be given more priority over the other one. So basically it's going to be juggling around inputs, checking these, is this one on, okay, what am I going to do? So that's how the logic of the brain will be operating. So we are going to connect the sensor to the memory, compare those two inputs, compare those two values. If they meet the qualifications which are set, then they're going to give a 1 output, which is going to enter the priority selector to decide which input to be given more priority over the other one. And I can change the time. I can adjust the time at which one sensor is given a more priority over another one. So I hope you have understood how the brain circuit will be operating. Yeah, so thank you very much guys for watching. Please subscribe to Tronics Energy, and hope to see you next time. Goodbye.